So starting off with a basic definition of permutations. Permutation is just counting how many ways there are to order a certain number of objects. So taking a look at our first example, we have 6 people in a human train or a Congo line, and they're all unique because people are unique and they're facing just one direction, so their positions are also unique. There's the first position all the way to the last position, or the 6th position for these 6 people. Now, using the fundamental counting principle, we can actually figure out how many permutations there are of this order. So for the first position, there are 6 people, 6 possibilities for the first slot. For the second position, there are 5 possibilities because one person has already been chosen for the front of the line. And with the similar reasoning, we have 4 people possibilities for the third, and continuing down until the very end we have just one possibility here, and that's the last person who has not been selected yet for the other 5 positions. And using our knowledge of the fundamental counting principle, we multiply these together. Now, we see this coming up a lot in permutations and other things. So mathematicians have given this sort of mathematical expression a special notation, and that is a factorial. So 1 times 2 times 3 times 4 times 5 times 6 is 6 factorial. And the general definition of a factorial, n factorial for an integer n, is the product of all the integers, positive integers from 1 all the way until n. And this 6 factorial is equal to 720. So there are 720 possible human trains that can be formed with these 6 people. Now, let's look at a second example. So, grab the eraser. I'm just going to change it a little bit. So now instead of having a human train of 6 people, let's say we just wanted 3. So these 3 people, they're not going to be in the human train, they're just going to be watching from the side. So in this case, we only have 3 slots, but we still have 6 unique people to choose from. So this is changing the problem into how many different permutations are there to place 3 people from a pool of 6. But again, it looks very similar. The first slot, there are 6 possibilities, the 6 people. The second slot, there are 5. Again, we already placed 1 person here. And for the last slot, there are 4. So this is 6 times 5 times 4, which is equal to 120. Now, we've been talking about permutations, so it's time to lift the blinds and give you the general formula for a permutation. So a permutation is something like this. So what this is saying is that there are 6 choices, and there are 3 actual objects you want to order. So again, there are 6 choices or objects, and you only want to permute 3 of them. So 6p3 is this problem right here, and that's also equal to 120. Luckily, you don't have to memorize all of these. There is a formula. So the general formula for permutations is, say we have n total, and we want to permute k of them. That's equal to n factorial over n minus k factorial. Although, in all honesty, it's better for you to understand what's going on rather than memorizing the formula for permutations. But let's just make a double check to make sure this formula actually works. Let's think back to the original problem again. So we want 6 people again. And remember, we said that there are 720 ways, or 6 factorial ways, to permute 6 people in this Congo line, or human train. And that is 6p6. Following the formula, that's 6 factorial over 6 minus 6 factorial, which is equal to 6 factorial over 0 factorial. And by definition, 0 factorial is equal to 1. Yes, that is just something you'll have to memorize, and that is equal to 6 factorial. So we're done.